Okay, let's look at a free fall example. Okay, remember we just introduced free fall, this idea that things falling towards the earth or thrown up towards the earth are always accelerating downward at negative 9.8 meters per second or negative 9.8 meters per second downward. Remember, that's a key concept. So whenever you see something in free fall, we automatically can pull the acceleration, whether it's thrown up, thrown down, thrown sideways, always accelerates down 9.8 meters per second squared. So we're going to use that in this newest problem. All right, in this problem we got a rock dropped from a height of 4 meters. We want to know two things. How fast is it moving when it hits the ground, and then how long does it take to reach the ground? So let's start with some givens. So we know it's dropped, and we know the height is 4 meters. So let's draw a picture. Here's my rock. Okay, it's dropped. It's going to speed up. Boom, my height, this distance, my delta x is negative 4 meters. Why did I write negative 4? Because, remember, delta x is change in position. If we're doing a free fall problem, you can always assume that the ground is a position of 0. So this is a height of 4 meters. So my change in position is going from 4 to 0. So we're gonna use that as a typical way to set up a free fall problem. Okay, so delta x is negative 4. I also see that it's dropped. Dropped implies not moving to begin with. Okay, if I said I threw it upward at some velocity or threw it downward at some velocity, you would say v naught is not 0. But if I say dropped, make the assumption that v naught is 0. And then remember, all objects in free fall, the rock will be in free fall, accelerate downward at a rate of negative 9.8 meters per second squared. I am going to call my up positive and my down negative. So since gravity is downward, it is a negative 9.8 meters per second squared. Okay, unknown. I want to know first how fast and then how long. So my v or vf and my t. All right, let's look at how fast first. Now, this is an example of constant acceleration motion. So we can go to our big 3. It just so happens that the acceleration is always negative 9.8. So if I know delta x, v naught, and a, and I want to find v, or v final, equation 3 will allow me to do it in one step. So I go straight to v squared equals v naught squared plus 2a delta x, and no simplifying needed. This is 0, so it goes away. So 2 times negative 9.8 meters per second squared times delta x, which is negative 4 meters. So 2 times 9.8 times negative 4. And I know the negatives will cancel, 78.4. So v squared equals 78.4. And I have meters squared over second squared. Meters times meters over second squared. Now, v squared, so I have to square root it. So I get v is plus or minus square root of 78.4, 8.85. And then meters squared over second squared gives me meters per second. Well, what is it? Is it plus 8.5, 8.85, or minus 8.85? Because the square root doesn't explicitly tell us. Well, in this case, you need to use some common sense. Up is positive, down is negative. When it hits the ground, it's going to be moving downward, right? A downward velocity. So in this case, my velocity is negative. So if I'm falling down, if the rock's moving down while it falls, velocity is negative. Okay, how about second part? So this is my equation, solve, solution. Now I'm going to go back over here for time and see how do I find time. Well, now I know v naught, I know v final, I know a, I know delta x. So really, I can use whatever I want to solve for t squared. I will default towards using the first equation if I have the chance to. You could use either 1 or 2. In this case, let's use 2, just because it's a little trickier. It'll give you a little practice doing a harder problem. So v naught t plus 1/2 at squared. All right, delta x. I'm solving for t, so I got to simplify this. Well, first of all, this is 0, so this whole term becomes 0. And I'm solving for t. So let's do delta x equals 1/2 at squared. Multiply both sides by 2. Divide by a. So I get 2x over a equals t squared. Then I'm going to square root that boy. So t equals plus or minus square root of 2 delta x over a. Okay, let's substitute. Delta x is -4. A is -9.8. So it looks like I might have a square root of a negative, but the negative should cancel. So I have -8 divided by -9.8 equals, and then square root that. Now when I'm solving for time, this should be easy choice. Is it plus or minus? I never have a negative time. Okay, so if you get a negative time, that's another indication that you screwed up somewhere. You should never solve for a negative time. You should always have the option of it being positive. So in this case, positive 0.904 seconds. Okay, and there's your first example of solving for an object in free fall. A couple things you can do. A is always -9.8. Now I will make this point. I haven't said this yet. This will come up. 9.8 is not ever the force of gravity, but the acceleration due to gravity. So when we talk about force of gravity, we're getting into a new unit, dynamics. So this is just the rate of acceleration, the rate at which something accelerates because of gravity. Don't confuse it with the force. We'll come back to that throughout the unit and throughout the year, really throughout the whole first semester.